Hello, Algebra 2. This is your work for March 26th and 27th. So this will take you through spring break. So I just want to jump right into these questions. These are all of the exponents questions, the exponential functions questions off of the study guide, or they're close to the ones on the study guide. So this first one says technetium 99M is used as a radioactive tracer for certain medical tests. It has a half-life of 1 day. Consider the function t, where t of d equals 100 times 2 to the negative d power. 2 to the negative d power is a really funny way of writing. So remember, the negative exponent puts the base at the bottom of a fraction and then to the d power. So it's just another way of saying half to the d power. But this function t of d equals 100 times 2 to the negative d power is the percent of technetium 99M remaining d days after the test. So whatever you get out here is a percent. That's interesting. And that makes sense because our principal, our beginning amount, this number is always the starting amount, is 100. That means we start with all of it. Write an expression that represents the number of days until only 30% remains. So I'm looking at the structure of this problem, and if our starting number is 100, that means that we're writing the percent as the whole number, not as a decimal. So we have to make sure that we get our proportions right. So we want to know if t of d represents the percentage left or the percentage remaining. We just want to know at what point does t of d equals 30. So the way that we would write that expression or that equation is 30 equals 100 times 2 to the negative d power. Pretty easy, right? Okay. So the next question, the expression 1 times e to the 0.34t models the balance in thousands of dollars, where t represents the time in years after the account was open. So if this is in thousands of dollars and this is my starting amount, that's my p, we started with $1,000 because this is literally 1,000. Okay. Write an equation that solves for the number of years after which there will be $18,000 in the account. So $18,000, I'm not going to write the thousands. So what I want to know is at what point does this equal 18? So I'm going to write that. 1e to the 0.034 t power equals 18. Okay, so now we want to go on to part B. After how many years will the account balance be $18,000? So we've set up our equation here. We just want to solve it now. So 1e to the 0.034 t power equals 18. So the first thing I want to do is divide both sides by this 1 right here. And so I get e to the 0.034 t power equals 18. Now I want to get rid of this e in the base. So I have to do the inverse operation. So the opposite of e to some power is the natural log of e to that power. And then I would also then do the natural log of 18. So I'm doing the same thing on both sides. Just like here, I divided both sides by 1. Here, I'm taking the natural log of both sides. So what I'm left with on this side, the ln and the e cancel out. So what I'm left with over here is 0.034t equals the natural log of 18. If I plug the natural log of 18 into my calculator, I get about 2.89037. So remember, we want to, if you're going to put it in the calculator and get a decimal, we want to leave a nice long decimal. So now I'm going to go up here. Didn't leave myself a lot of room. And I'm going to divide both sides by 0.034. So these 0.034s cancel out. And of course, I have to put this in my calculator. And I get that t is approximately 85 years. All right, so now this last one, a rabbit population doubles every 8 weeks. There are currently 13 rabbits in a restricted area, so that means no hunting is allowed. So we're going to say that the rabbits only increase in number. If t represents the time in weeks and p of t is the population of rabbits, about how many rabbits will there be in 112 days? Round to the nearest whole number, we cannot have partial rabbits. Okay, so first thing I notice is that my times are in 2 different units. So t represents time in weeks. I don't love this. So let's look at a little bit of a formula for this. So our current population as a function of time is equal to our starting population, okay, which is the same thing that we've been doing with interest questions. In this case, though, our interest is being paid out in bunnies. But because it tells us that it doubles, instead of trying to figure out what the rate is and what the appropriate thing to multiply by is, we're just going to say, okay, doubles means times 2. So I'm just going to put a 2 in here. And we're going to raise that to the t power. But here's the thing, t is not exactly the time in weeks. Remember, when we look at interest problems, t is the number of times interest is going to be calculated. In other words, when it comes to the bunnies, our t is the number of time periods that are going to happen in which the bunny population is going to double. So we're going to say the number of times the population will double. So in other words, the number of times that our rabbit interest is calculated. So it's calculated every 8 weeks, but we want to know 112 days. So I need to know how many weeks Well, 112 if I say, well, there's 7 days in 1 week. All right, well, let's look at that. So 112 divided by 7 tells me that that's 16 weeks. But that's not exactly the number of times the population will double. The population doubles every 8 weeks. So I'm going to take my 16 weeks, and what I want my units here to be is times it will double. Okay, so I know I want to get rid of my weeks, so my weeks needs to go on the bottom. So how many weeks does it take? It takes 8 weeks for it to double. So 8 weeks, and I'm just going to put 1 double. Okay, so 16 times 1 is 16 divided by 8. My weeks cancel out. So that means that it will double 2 times. So 2 doubles. Okay, so that means t equals 2. All right, so now I have my initial population. I know that my rate is 2 because it's doubling. And I know that my t, my number of times that it will be able to double, is 2. Now it might come out not quite 2, or not a whole number, I'm sorry. So if you had 3.6 weeks, that would be okay. That would be okay. All right, so I'm going to put a 2 in here. Our initial population is 13 rabbits times 2 to the second power. So that means 13 times 4. I'm noticing when I put my dots for multiplication, it looks like a decimal. So I'm going to use parentheses. So after 2 doubles, there will be 52 rabbits. Now let's check that. Okay, so if we know that 112 days is 2 sets of 16 weeks, we know that it's going to double 2 times. So if we start with 13 rabbits, the first doubling after the first 8 weeks gives us 26 rabbits. But now we're not going off of the original 13. It's going to double again. So 26 times 2, that would be at the end of 16 weeks or 112 days. Let's do this one is 56 days. 26 times 2, just as I suspected, 52 rabbits. All right. So hopefully this helps a little bit. These were some of the questions that people had a hard time with and were asking for some help with. Go ahead and if you need to watch this again, watch again. But this will be your last assignment before spring break. So make sure that you have this down, that you have the notes written down for these questions. and then go ahead and work on the just a couple of practice problems.